Hello, cosmic wanderers. Today, we dive deeper than ever into the universe's greatest mysteries. We'll be exploring 10 mind-bending facts about space, planets, galaxies, dark energy, and the very fabric of reality. Some of this is cutting edge, so buckle up. The universe is wilder, stranger, and more beautiful than you probably imagine. Fact 10. The observable universe: size, age, and the edge. The universe is Poisson's 13.8 billion years old, according to measurements of the cosmic microwave background, expansion rates, and nucleosynthesis. Because space is expanding, the observable universe extends much farther than 13.8 billion light-years in radius. Current estimates place its radius at 46 billion light-years. That means the diameter is 92 billion light-years. The light from further than that hasn't yet had time to reach us due to expansion. The edge isn't a physical boundary. It's just the furthest we can see, given the finite speed of light and the age of the universe. Beyond that, there may be much more, perhaps infinitely more. Recent observations, e.g. by telescopes like the Atacama Cosmology Telescope, are giving us higher resolution looks at the universe's baby pictures when it was only 380,000 years old, the era of the recombination when the CMB was released. These shed light on the early fluctuations in density, which later led to galaxies, stars, and everything else. Why this is mind-blowing? It means the universe is older and vaster than our intuition suggests. We're always looking back in time with our telescopes. What we see out there is history as much as it is space. Fact 9. Dark matter, the invisible framework. Only about 5% of the universe is made of ordinary baryonic matter. What we see: stars, planets, gas, dust. The rest is split between dark matter, 27%, and dark energy, 68-70%. Dark matter doesn't emit, absorb, or reflect light, entirely invisible. We infer its presence from gravitational effects. Galaxy rotation curves don't make sense unless there's extra unseen mass. Gravitational lensing, light bending, shows more mass than visible. Also, large-scale structure formation in the early universe from fluctuations in the CMB matches models with dark matter. Dark matter is cold in most models, meaning the particles move relatively slowly compared to light speed, non-relativistic, so they help small fluctuations in the early universe grow into galaxies. Some theories propose WIMPs, weakly interacting massive particles, axions, or other exotic particles, but none have been definitively detected yet. Fact 8. Dark energy, pushing the universe apart. Dark energy is what's driving the accelerated expansion of the universe, discovered in the late 1990s by studying distant Type Ia supernova, which appeared dimmer than expected. It currently makes up 70% of the universe's total energy content. Ordinary matter is 5%, dark matter 27%. New findings from DESI, the Dark Energy Spectroscopic Instrument, suggest that dark energy may not be a strict constant. It might have changed in strength over cosmic time. In particular, some data suggests that dark energy may have peaked in strength when the universe was 70% of its current age and might be slightly weakening now. If true, this would change predictions about the ultimate fate of the universe, e.g. Big Freeze, Big Rip, or other scenarios. Missions like Euclid, launched by ESA in 2023, and the upcoming Nancy Grace Roman Space Telescope, expected PIS 2027, will map billions of galaxies and help us see how dark energy has pulled the universe apart over time, and how matter is structured. Fact 7. Exoplanets, more worlds than we imagined. As of mid-2025, 5,983 confirmed exoplanets have been cataloged. These exoplanets vary tremendously: gas giants, mini-Neptunes, super-Earths, rocky planets, etc. Some orbit very close to their stars, hot Jupiters, others in more temperate zones. About 180 of these exoplanets are in or near their stars' habitable zones, regions where liquid water might persist. That doesn't guarantee habitability, but it's one of the key ingredients. A recent breakthrough, the James Webb Space Telescope, JWST, directly discovered a previously unknown young gas giant exoplanet around the star TWA7, 110 light-years away. What's significant? Direct imaging is very rare. Most exoplanets are found via indirect methods, transits, radial velocity. This new planet is also among the lowest mass imaged directly so far. Why this matters? Each new exoplanet tells us more about how planetary systems form and evolve. Direct imaging allows atmospheric studies, which bring us closer to determining habitability or biosignatures. It's not just, are there planets? It's how many, what kinds, and which could support life. Fact 6. The early universe and cosmic microwave background. Snapshots. When the universe was 380,000 years old, it had cooled enough for electrons and protons to combine into neutral atoms. Photons then decoupled, creating the cosmic microwave background, CMB, the oldest light we can observe. All current large-scale structure, galaxies, clusters, grew from the tiny fluctuations we see in the CMB. New high-resolution CMB images, from ACE-T and others, are resolving finer details of those primordial fluctuations. They track how hydrogen and helium gases clumped and moved, which helps test models of inflation, dark matter behavior, and how early universe physics worked. Also, Euclid's Sky Atlas, first panels, is giving us detailed mappings of interacting galaxies and clusters millions to billions of light years away. These give clues about how structure forms and how dark matter is distributed. Fact 5. Gravity, relativity, and warped spacetime. According to Einstein's general relativity, mass and energy warp spacetime. Light rays passing near massive objects get bent, gravitational lensing. This effect allows us to see mass that's invisible, dark matter, because it bends light. Recently, the Euclid telescope captured a striking Einstein ring around galaxy NGC 6505, revealing light from a more distant galaxy bent around it. This lets scientists map mass in foreground galaxy, including contributions from dark matter. Relativity also predicts time dilation. Clocks in stronger gravity or moving at high speeds tick slower relative to others. These effects are not just science fiction. GPS systems need to account for them. Black holes, regions where curvature becomes so extreme that beyond a boundary, event horizon, nothing, not even light, can escape. Supermassive black holes, millions to billions of times sun's mass, sit at galaxy centers. The study of black holes pushes physics to extremes, singularities, quantum gravity, etc. Fact 4. Extreme objects, neutron stars, quasars, black holes, and exotic planets. Neutron stars are remnants of supernova, so dense that a sugar cube-sized piece would weigh billions of tons on Earth. Sometimes they spin fast. Pulsars have intense magnetic fields, magnetars. Quasars, super bright, energetic cores of young galaxies. Powered by matter accreting onto supermassive black holes, they outshine their host galaxies. Exotic planets, e.g. diamond planets, carbon-rich, planets around pulsars, rogue planets drifting without a host star. The newly found exoplanet by JWST is a young gas giant far from its star, 52 times Earth's distance from Sun, an unusual orbit for a directly imaged exoplanet. Fact 3. Cosmic time travel, seeing the past to understand the future. Since light takes time, when we observe distant objects, we see when they were, not when they are. Galaxies billions of light years away are seen as they were billions of years ago. Using telescopes like Hubble, Webb, and ground-based observatories, we can see galaxies when the universe was a few 100 million years old. That helps us study galaxy formation, early stars, and reionization. This time travel effect also underlies studies of how dark energy has changed over time, because we can observe the behavior of expansion in different epochs. Fact 2. The composition of everything. We are stardust. The elements heavier than hydrogen and helium, carbon, oxygen, nitrogen, iron, etc., were forged in stars via nuclear fusion and in explosive events like supernovae and neutron star mergers. Without those, the universe would be just hydrogen and helium. Those heavier elements got spread into space by those stellar deaths, forming later generations of stars and planets, eventually leading to planets like Earth and life. Recent observations of gravitational waves, e.g. from neutron star collisions, also confirm where some of the heaviest elements, like gold, platinum, come from. While not in all the numerics here, these discoveries reinforce that the matter in us and around us has a stellar origin. Fact 1. Unanswered mysteries, what we still don't know and why it's exciting. What exactly is dark energy? Is it a constant, cosmological constant, or something that changes over time, quintessence or other evolving fields? What are the particles of dark matter? Despite decades of searches, direct detection, indirect detection, collider experiments, we still have no confirmed particle. Theories include WIMPs, axions, sterile neutrinos, but none confirmed. Is there life elsewhere? We have habitable zone exoplanets, but habitability depends on many factors: atmosphere, magnetic field, star activity, etc. We don't yet have confirmed signs of life. What came before the Big Bang, if that even makes sense? What is the nature of inflation? Did it happen? How did it start? Other frontiers, quantum gravity, unifying general relativity and quantum mechanics, understanding singularities, inside black holes, understanding the nature of time. We've traveled from the moment the universe first became transparent, to the scaffolding of dark matter, to the accelerating expansion driven by dark energy, and onward to the hunt for new worlds and answers to cosmic mysteries still beyond reach. If you've enjoyed this journey, hit like and subscribe if you want more deep dives into space and cosmology. Thanks for watching. Keep asking big questions, because every mystery solved leads to new mysteries waiting. Until next time, look up, explore, and be curious.